Yeah, ladies and gentlemen, good afternoon, especially day, good afternoon. So I'm going to do a little circuit flight on Salvador Airport, just to have a look what went wrong last night with that ILS approach, and then we'll do a bit of investigation. So in the Airbus, as usual, we begin with the batteries and ground power here. We'll turn on all these guys, fuel pumps that is. And then we're going to turn on the ADIRs. Normally, one would start cranking up the brightness of all these displays manually. I've written a little tool which will do that all for me in one go. But the process is self-explanatory. Dial up the brightness on all the displays. Turn on the radios, although we don't really need that. We're not going to be flying online. IRS alignment is going to take a little bit, but we can shorten that. So, well, let's first of all start off with setting some weights, and I'm going to just do this by gut feeling. There's nothing planned from SimBrief or something. So 180 passengers. Let's say 4.5 tons weight. And observe down here, 0 fuel weight center of gravity. I'm going to adjust this to be as close to 25% as possible. Right. So that's 180 passengers, 200 kilos of cargo in the front bay, 100 in the back, 4.5 tons of fuel. We're going to quick refuel, and we're going to apply the load settings. Done for that part. Now initialize, and we're gonna go from what did I say? SBSV, Sierra Bravo, Sierra Victor. Align IRS, and now we can also go right here. Where was this again? Okay, quick align. Done. And as you can see, the systems have now become live. We'll enter a number. So this is a Lufthansa flight, maybe. Lufthansa uses a cost index of 30 generally. We're going to, let's say, enter flight level 110, 11,000 feet. I don't know how high we're going to be flying really, but we'll see. Next thing, we open up that Tollers menu again. Loading performance, and then we have a look at the zero fuel weight. The zero fuel weight rounded is 66.1 tons. And it already says 25% here, so I don't have to enter anything more, because we have 25% here as well. Our block fuel is 4.5 tons. There we go, that is that. Now, we've only entered a destination and arrival that happen to be the same, so the way to go is to set a departure. And it's going to be runway 10. And it's going to be the ELEFA 1 Alpha. And no transitions. Inserted. The next thing is to set the arrivals. And it's going to be ILS 10 Zulu. Just need to check something. And it's going to be the Azuga 1 Alpha arrival via Gevmo. Transition none. So temporary insert. Now let's have a quick look at the flight plan to see if we've got any discontinuities. So there is one. So from ELEFA we are going to go to OBDUD. Next waypoint OBDUD. And then we can clear out this discontinuity. Okay, that's looking good. Now because we've selected a departure runway, we can come back into this area and actually select the takeoff configuration. It's going to be flaps 1 plus F, and we're going to be using toga thrust, so set this to 1. We go to performance and enter the values that are displayed here. Next, flaps. So it'll be, as we said, 1, and then a slash, and then we look down here, the THS value is up 0.7, so 1 slash and up 0.7. Because we are not using flex temperature to take off, that is the Boeing equivalent of a derated performance, we're not going to fill this value. What we can do already is set a fix, because we know where we're going to be landing, namely here. So I'm going to click any of those waypoints, fix info, SBSV, and runway 10. And we're going to put a 10-mile radius around it. And we're going to click next page. Same procedure. Four miles. And the 2 miles. So this will just be so that we can see right on this ND display that we are getting close to the airport within a 10-mile range, a 4-mile and a 2-mile range without looking at any of the numbers. We can close that. Here you can see the distance rings, by the way. So we're going to go to plan mode. We're just going to enter the same thing that we did here to check our overall distance to the airport. So back to flight plan. We'll have a look here. By the way, we can see at Azuga we're going to be flying a required altitude of minimum 104 apparently. So at 10 miles we're going to be at low gav, etc, etc, etc. 4 miles, 2 miles. And this is going to help us with the configuration, setting the landing configuration of the aircraft. And the blue stuff is the go around, right? So when you've missed your approach or touched down too late, you automatically fly the blue line. Our QNH is currently 1012. Yeah, so flight level 110 seems to be working. Start up the APU, open the APU bleed. The status of the APU can be seen here. Disconnect ground power. Econ flow on. Packs off. Although this isn't really required, but set the ignition to start, starting engine number 2. Good start, starting engine number 1. So, nose wheel steering disc disconnect. That is obviously the case because the tug is pushing us and the nose wheel steering has to be disconnected. But that happens automatically here. Engine number 1, good start. We don't have any rain conditions by the looks of it, so we're going to set ignition to normal. We're going to set our flaps to 1. We're going to arm the speed brakes. We're going to set auto brakes to max. Yes, of course, sir. Turn off the APU again. Gear pin removed, so that means our nose wheel steering should be active again. Yes, it is. So, ECAM, cabin. Checked. Final blue message on ECAM is takeoff config. Takeoff config normal, no blue. Taxi, runway turn off lights, strobes to center position. And off we go. Let's just make sure that we're actually going to the correct runway. At the holding point, Lufthansa 141 ready for departure. Transponder on, in other words, Squawk Charlie. Runway takeoff lights, or landing lights rather, on. Strobes on. Taxi light to takeoff. All set. Okay. So, that was the chronometer, which is now running. We need to stop it. Thrust, start chronometer, and toga thrust. Here you can see toga thrust set. Flaps up. We see lever climb, that means pull back throttle. Autopilot 1 engaged. Right, we've pulled back the throttle so that it is lining up with this detent. At the same time you can see the value here change to speed. So there is an altitude constraint here. I could override this now if I wanted to. Okay, turn on the packs. To override that constraint, I'm going to pull the knob here 2 dots means pull. Now we should start climbing. And there we go. This kind of thing, overriding, is only when ATC gives you clearance, right? We're just going to assume that ATC has given us clearance. And we're gonna go to ELEFA. Okay, transition altitude. Standard barometric pressure. Over here, you can see there's a blue arrow pointing up and to the course that is on top of climb. So we've pretty much reached the top of climb. We're going to save this situation now. So that if anything breaks now, we can just return to exactly this point. Enter destination data. So what this actually asks is it wants to know in the approach what is our QNH, and it is going to be the temperature at Salvador airport is 24 degrees. I'm taking this information from Active Sky, by the way. So the winds are 59 at 5 knots. Let's look at the approach chart. We can close this one now. So, decision altitude 231. Done. Now let's have a look where our top of descent is actually. "87 miles. That's quite a bit. But that's okay. So it says, well, you don't have to do it by the checklist here, but in cruise flight you switch to airport mode. Done. Increase the range to 40. Now we'll see everything that shows up here is an airport. Just click next. Barometer is set. Now actually we could do something, because I've never tested this myself. I'm going to save this situation again. So I've just overwritten that file, I hope. Now, we're going to accidentally activate approach phase and see if we can recover from that. As you can see now, the speed bug is down to approach speed. So let's see what the aircraft does if we can actually recover by going to perf. No, going to init. I think it was here. Let's see if we can change this. No, we're still in approach. That is, of course, not what we want. Okay, it seems it's not working that way. Let us recover. Back in business. Okay, because we're in cruise altitude, by the way, we can now set the transponder to BLV. That is one rotation to the right. Done. The checklist says, yeah, it's all good. So we've entered the runway and all that stuff, yeah? Yeah, it says here 10, which means we've selected runway 10. We know that we have a star. You can see it in white above all of those waypoints. It belongs to Azuga 1 Alpha. Yeah, if we would have to enter this information now, which we've already done, then we'd have to do that with a temporary insert. We're just going to skip all this. We've done all this stuff already, and we're just going to say, yes, we've done it. I'm not going to calculate any auto brakes. I'm going to set them just like that. I'm going to skip this part. So, intercept altitude is apparently 1,700 feet, so we'll dial that in. Normally, you should not dial in the altitude before you actually get to your top of descent. It's actually still 67 miles away. And the reason for this is if you come into some strong turbulences now and the aircraft will sink a little bit, then it might not know which altitude to go back to. You know, so normally just leave it at your cruise level until shortly before. Actually, let us do that just to be safe. Or we'll dial in something a bit closer. So the script here says if above descent path, then pull the altitude knob, that is this one. Of course, once you've dialed in a lower altitude. But we're not going to be above descent path. And it looks like our top of descent is coming in over here. Let's cheat a little bit. Jump to next waypoint. So there we are, approaching the next waypoint. So until I've found a way to get out of approach phase successfully, just do your best and don't click this by accident. By the way, this aircraft does auto saving of a situation every couple of minutes, I think. So every 5 minutes, if you've turned it on, it's set to 1, then you'll have an auto-saved situation every 5 minutes. So you could, in theory, then select this guy and say load selected situation, and you'll be right back where you were 5 minutes ago by the latest. Okay, so we're coming into top of descent. We're going to start turning down. So currently the radio and navigation data is not populated. This is expected actually, because it's going to be populated shortly before the approach. So normally don't fill in any data here unless you are sure that you don't have any on the final. And when we get to about 2 miles from top of descent, we can see it here too, by the way, we're now 17 miles away from top of descent, 16. When you get to 2 miles, or let's say 5 miles, when you come in range of 5 miles, you can press the MCP altitude button. Because unlike Boeing, where once you've dialed in a low altitude, it will automatically descend. In the Airbus, you have to tell it descend now by pushing the button. And that is either pushing it or pulling it. Push, pull. And pushing means managed mode, and pulling means manual mode. Seven miles to go. Okay, you know what? Let's just enable descent now. So what the aircraft is going to do, very likely, oh yeah, it is descending. It's going to descend with roughly 1,000 feet per minute until it reaches the calculated descent path. But a couple of miles before is no problem. You can see that here's the new calculated descent path. Our next flight level, even though we dialed in 1,700 feet, you can see there is an altitude constraint. Let's turn on constraints. And you can see at this point we have to be at 9,000 feet. Or we will be there. It actually says flight level 78. Okay, because we're going through the 10,000 feet, we're going to have to slow down to 250, turn on the landing lights, runway turn off lights on. Seatbelts on. I'm going to turn on the taxi light too. Now we can step on the speed brakes a little bit. Until we get into this range, preferably here. I'm going to turn off the speed brakes now and arm them. When that white stripe is visible, the speed brakes or ground spoilers, whichever you want to call them, are armed. So we're doing a slow descent right now, 500 feet per minute. Once we pass this marker, we're going to be descending a little bit more. And at this point, because we're not so far away from the airport anymore, we can enable approach phase. So to do that, done. Now the aircraft is going to be anticipating a lower speed, one that is suitable for approach. Because we are doing an ILS approach, we're going to do landing system on. So over here about 217 knots is the speed that the aircraft is going to want to fly. Now, because we just passed that squiggly line, that descent path, and the green dot over here shows the descent path, and we're slightly below it, but now we're going to be picking up, and we're going to be right on plan. Let's get a little bit more detail here, reduce the radar range. We can at this stage, if for instance ATC tells us descend to so and so many feet and not flight level XYZ, then we enable local QNH. Every time ATC tells you descend to 7,000 feet or 4,000 feet or anything with feet, you are automatically allowed to set the local QNH. So as you can see, we've reached our speed, and if we become, this is the sort of speed where we need to set flaps to get down there. The green dot speed is just above the speed that you need to if you want to fly without flaps. Now we can set the speed to manual if you want to. pull the knob. And it'll automatically adapt the value that the aircraft has preset already. So let us go down a little bit slower. And flaps 1. And you can also see that here. And here we're getting ILS information already, so approach. Slow down a little bit more. Flaps 2. Always make sure that you're far away from this red area. Otherwise you're going to break your flaps. Ooh, we're going down a little bit steep, so gear down as well. That is going to help slow down the aircraft. Set the radar to the minimum resolution range. Okay, speed stabilized so far. As you can see, we are not on the glide slope or localizer yet. We're going to slow down to 160. This is the speed at which we would have to set the next level of flaps. Okay, we see localizer coming in, lock star. And we've just passed the 10-mile ring, okay? So at this, from here to the 4-mile ring, ATC will often tell you maintain speed 160. And that's what we're doing, 160. And not less. That's what it's about, the important thing. So localizer is now not localizer star, it's captured localizer. Glide slope star. That means glide slope is coming in, as we can see on the dot here. The diamond, we're very close to it. Glide slope captured. Once we get to the 4-mile ring, I'm going to set final flaps, and then I'm going to set managed speed. In fact, I'm going to do managed speed right now already. Push the button in, next level of flaps. So we now have flaps 4, I believe. No, now we do. Full flaps. And the speed is being managed by the aircraft automatically, as seen over here. V approach 142. So, blue items, cabin, okay, not so important, but yeah. Cabin has now been informed that we're going to be landing. Runway in sight. Now if it was raining here, you'd have to set ignitions to start, but it isn't. Right, we've also made sure speed brakes armed or ground spoilers armed. We have auto brakes set. Landing gear is down, seatbelt signs are on, cabin is ready, spoilers aren't, flaps full. No blue. Now we've actually passed the minimums already, interestingly. No, we haven't, it's 231 is the minimums. 1700 was just intercept altitude. To disconnect the autopilot, you press this red guy here. And not this one. And as you can see, I don't have to press any of the buttons anymore to make that alarm sound go away. Slightly low. Okay, that was a bit of a floaty. Reverse thrust. 60 knots, manual brakes. Reverse thrust off. Landing lights off. Strobes to auto, taxis on. Transponder standby. Done. Now you could continue. So I hope this explains a little something about the way the Airbus works.